So when we look at different events, we want to know if they are mutually exclusive, and we're also going to want to know if they are what we call independent. To be mutually exclusive means that none of the outcomes are in common. For example, male and female. Either you're in the male group or the female, you can't be in both. Rolling a die. You're just going to get one of the values. You can't have two show up on a single die, as in flipping a coin. You're either going to get heads or tails, you can't get both. So if one card is drawn from a standard deck of cards, a standard deck of cards has 52 cards. There are 4 what we call suits, and in each suit there are 13 cards, i.e. 4 times 13 is 52. The 13 cards range from the ace, the king, the queen, the jack, 10, and so forth, all the way down to a 2. We call the king, queen, and jack face cards because they have a face on them. So let's look at our 2 events, drawing a king and drawing an ace. They are mutually exclusive. If I look, all my kings, the 4 of them fit in this circle, all my aces fit in the second circle. They're totally exclusive of each other. There's no overlap. Draw a king and a heart. A heart is one of the suits. So if all my kings are in here, all my hearts actually overlap, and in the center here is a card that was in both the king of hearts. So that is not mutually exclusive. Draw a king and draw a black card. Again, not mutually exclusive. If I have my kings, I have this overlap, and I actually have 2 black cards in here, the clubs and the spades of the kings. Out here would be the hearts and the diamonds, and over here would be the rest of the black cards that were not kings. So there's a picture of something that is mutually exclusive and not mutually exclusive. So let's go ahead and look at probability. Probability notation is probability of event A. And what probability is the frequency or number of times the event will occur. How often did it occur in a set amount of trials? Probability has a range, and it ranges from 0 to 1 or 100%. So it has this range, again, from 0 to 1. If your probability is 0 or 0%, that means the event will not happen or occur. If the probability is at 100%, this means the event will always occur. The sum of the probabilities, the sum will always add to 100, or 1. So the probability of winning and losing, if you're going to win 60% of the time, you're going to lose 40% of the time for the total of 100%. The probability of event A. How do we find probability? What's my formula? Probability of event A is equal to the number of times there is a success over the total in the sample space. Sometimes this is known as the relative frequency. So if we take a look on how to calculate probability, it's a simple fraction that then can be returned into a percent. Right now we're just going to leave it as a fraction, and I'd rather you left your homework as a fraction so I can tell, do you understand what the success is over the total? So if I look, the probability of having 3 girls, well, if we go back to our probabilities of having, or what our sample space looked like, of having 3 children, what's the probability that I have 3 girls? Well, in my sample space, I had 8 items. Which one or how many times do I get the probability of all 3 kids being girls? Looks like it happens 1 of the 8 So if we look here, the probability would be 1 out of the 8 times. So we need to go back and look at our sample space. Probability of having one girl. Probability of having one girl. So if we look at our sample space, how many times does having one girl occur? 1, 2, 3 times. Having one girl occurred 3 times. So 3 of the 8, 3 of the 8. And the probability of having at least 2 boys. At least. Notice the change in the language there. At least 2 boys. How many times does that occur? At least 2 boys. It looks like it occurs 1, 2. This is at least 2 boys. Looks like it occurs 4 times. So my probability would be 4 out of 8, which if you wanted to reduce is 1/2. So that's a simple way that probability is found. You need to look at your sample space and success, which is deemed as what I want to have happen over the total. The complement is the probability of not getting the outcome. So the probability of having 3 girls is the probability of not having 3 girls. We write it like this, probability of the event, but I want its complement, so I put a little c there. And the 2 probabilities will total 1 or 100%. So if I look at an example, the probability of rolling a 6. Well, we know the sample space contains 6 numbers, 1, 2, 3, 4, 5, 6, and there is 1 6 on a single die. So what's the probability of not rolling a 6? Getting the 5 other numbers out of the 6 possible, and if you go ahead and add those up, you get 6 over 6, which is 1, or 100%. So those 2 are complements, or opposites of each other.